Hey everyone, let's look at lesson 4. Today we're talking about conditional probability. Our definition of conditional probability is when we have a condition that may limit the sample space for some event. You can write conditional probability using the notation the probability of event B given that event A happens. So when we calculate that, the probability of event B given that event A happens, we would first find the probability of A and B, and we saw that in our previous lesson where we multiply probability A times probability B, and then we divide by probability A. So this is for any two events, A and B, where the probability of A is not 0 for any two events. Then we use a two-way table, which is a useful way to organize data that can be categorized by two variables. And here you see fiction books that are in paperback and hardback, and we see nonfiction books that are also in paperback and hardback. And that information in some survey or data collection was organized in this nice two-way table. So paperbacks, fiction and nonfiction, hardcover, fiction and nonfiction. You see all the fiction books, both paperback and hardcover, and then all the nonfiction books, both paperback and hardcover. Now, when we take these values from some data, such as this two-way table, and pick a category and divide that by the total number of values in that two-way table, this is called a joint relative frequency. And when we have the sum of all the joint relative frequencies in each row and in each column of a two-way table, we call that the marginal relative frequencies. And in this table, you can see that we have our marginal relative frequencies totaled here for this row in paperback, this row in hardcover, and then this column total and this column total. So our totals, row and column, would always equal 1. Let's give some of these a try. In example 1, we have the results from a class survey that are shown in this table below. And we want to know the probability that you own a pet given that the pet is a female. So in our definition, we're going to do the probability that you have a pet times the probability that the pet's a female, and then divide by the probability that you have a pet. So looking at our table, we have 14, yes, I own a pet, and 12, no, I don't own a pet. And having a male pet, there were 13, and female pet, there were 13 on that row. So each row and each column totals 26 in our data collection. Then to find the probability that you own a pet, that would be 14 out of 26. And the probability that the pet's a female would be 6 out of 13. And dividing by the probability that you own a pet, that was 14 out of 26. So this is working hard when we could have just calculated the probability that you own a pet given that the pet was a female would be, yes, I own a pet, and that the pet was female would be 6 out of 13. So our probability using the formula looks like this, and simplified, it is a 6 out of 13 probability that you own a pet given that it was a female. In part B, we want to find the probability that you own a pet given that it was a male. So in this case, let me erase what we did before here. The probability that I own a pet and that the pet was a male would be I own a pet, that's male, 8, and total surveyed were 13. So the probability that we own a pet, given that it was a male, would be 8 out of 13. And then finally in C, we want to find the probability that you don't own a pet. So there are 12 people that don't own a pet out of 26 that were surveyed. And you could simplify that down. If we divide each term by 2, we would say the probability that you don't own a pet is 6 out of 13 people in that data collection. Let's go on to example 2. We want to use the table to find each probability. So the first thing you want to do is to add up the rows and the columns. In the first column, we have 69 in the survey. In the second column, there were 27. In the first row, that's 62 and 23, we have 85 people. And in the second row, 7 and 4, that would be 11. So adding these two total, we see that there were 96 people surveyed. So we know that the total amount of our data was collected from 96 different people. In the first example, we want to know the probability that the person had a diploma. So we're looking for the yes in the diploma, and it looks like there are 85 people that had a diploma out of the 96 who were surveyed. So our probability is 85 out of 96. Using a calculator, we can see that that's about 88.5% of the people surveyed had a diploma. In part B, the probability that you had a diploma and you had some experience. So in the experience column, we're looking at the yes, that would be 62 people had a diploma with experience, and there were 96 people in all. So our survey would say 62 out of 96, which can be simplified to 31 and 48. Or if you want a percent, that would be about 64 and 0.6% of people in our survey had a diploma that also had experience. In part C, we want the probability of experience given that they had a diploma. So the probability of experience and yes on the diploma again is 62, but this time we're looking at the total that had experience with a diploma. That would be a sample size of 85. So 62 out of 85 had experience given that they had the diploma first, which gives us about 81 and 0.2%. And then part D, the probability that they had no diploma given that they had experience. So we see they don't have a diploma, that's 7 people, given that they had some experience, which would be this column. So out of 69 people, 7 out of 69 is about 10.1% of our population there. For example 3, we have a reporter was asked 150 voters how they plan to vote on a new sports stadium and a new performing arts center. So we want to complete the table of joint and relative frequency. So I'm going to add up my columns and my rows to get our total data collection. So 58 and 23 is 81. 32 and 37 is 69. Adding across our row, we had yes 90 people, and in our no row, we had 60 people. So using the calculations and using my calculator, answering yes to the sports stadium, we had 39%. And that 39% came from dividing 58 yes votes out of the total 150, because we know that we have 150 people in our data collection. Then following across the no votes, we're going to get the no votes here using 32 divided by 150. That's 0.21%. Then looking at Performing Arts Center, no votes, that's going to be 23 for 23 here out of 150 for 15%. And look at Performing Arts Center and Sports Stadium, no, that's going to be 37 people out of 150, so 25%. And then we can just add each row and each column. So 39% and 21% is 60% of our people. 15% and 25% gives us 40%. In our yes column, we got 39 and 15, that's 54%. And 21 and 25, that's 46%. And then 60 and 40 would be 100%, as well as 54 plus 46. So each row and each column have these frequencies to consider. Let's go ahead and look at part B. If a voter plans to say no to the sports stadium, what's the probability the voter also plans to say no to the Performing Arts Center? So we want to look at our two-way table and consider the no column and the no column. So we want no and no, they overlap right here, 25%. And the total in the no column was 46%. So our probability would be 25% out of a total of 46% saying no, which is, using our calculator, about 54.3%. 54.3%. Or you could say that's 37 people out of 69 if you looked at the no and no overlap out of our 69 people. Let's move on to example 4. To save a little time, I've already added my rows and columns in each category here. We're looking at the projected number of degree recipients from 2015. And we want to know the probability that the recipient is a male. So in the male column, we see we have 1,242 people, but how many people were surveyed? So we need to add the row, add the column, and we find there are 3,206 people. So the probability the recipient is a male is 1,242 people out of 3,206 people surveyed, or about 38.7%. For part B, the degree is a bachelor's degree. So on the bachelor's degree row, we have 1,705 people, and the probability that the person had a bachelor's degree would be 1,705 people out of the total 3,206. And we find about 53.2% of the people surveyed had a bachelor's degree. In part C, we're looking for the recipient is female, given that the degree is a master's degree. So we can use the two-way table and find the recipient is a female. So we have 1,964 people in that female column, but we want the overlap that the recipient is a female, given that they have a master's degree. So female with a master's is 464, and how many had master's degrees? 757. So that gives us 464 out of 757, or about 61.3%. And then part D, the probability that the degree is not an associate's, given that the recipient is a male. So looking back at our chart here, I'm going to go back and look at that. The probability that the degree is not an associate's degree, given that the recipient is a male. So we're looking in this column here, and we have to add 677 and 293, so we're going to add these two. That's going to give us 970 out of, given that they were a male, that's 1242. Our probability the degree is not an associate's, given that the recipient was a male, is about 78.1%. For example 5, we're going to look at a student in Orlando, Florida, made the following weather observations in July. On 78% of the days, the sky was sunny. During the sunny days, it rained 64% of the time. And during the cloudy days, it rained 87% of the time. In part A, we want to make a tree diagram using S for sunny, C for cloudy, R for rainy, and N for no rain at all. So let's try that. We can use 78% of the days it was sunny, so we got 78%. Whoop. And I want to put a capital S there for sunny. Then 64% of the days it was rainy, so we'll put a capital R at the end. And then if it wasn't sunny, we had no rain, so that would have been 36%, since 64 and 36 make 100%. Then going in the opposite direction, if it wasn't sunny and it was cloudy, well, you don't want to do that in red. That would have given us 22% of the days would be cloudy. So 13% would be no rain. And 87% would be rain. So you can see that each branch on our tree diagram would have to match the data from the survey, and also would have to add up to be 100%, such as 64 and 36, or 87 and 13, or 78 and 22. In part B, we can use the diagram to find the probability that a day will start out sunny and then it will rain. So using our formula for that, the probability that the day starts out sunny and then it rains is going to be the probability of a sunny day times the probability that it rains, given first it was sunny. So looking at our tree diagram, the probability that it's sunny is 78%, given that it was going to rain after it was sunny, so that would be the branch of 64%. So multiplying those with a calculator would tell us that about 50% of the time it starts out sunny and then it rains later on. Part C, we want to find the probability that there is no rain, given that it was a cloudy day. So here we have no rain. This was our cloudy day, and no rain would be 13%, or 0.13. 0.13. No rain, given that it was a cloudy day. And using our formula from the last lesson, we'd say the probability of A and B, so 22% times 13%, divided by the probability of A, which is 22%. And that way you can see how we can use the formula or look at our tree diagram to get that information. Then finally, in our last example, Miles took a survey of randomly selected students and summarized the results in the table below. We want to make a table of the joint relative frequencies and marginal relative frequencies. So again, we've got to add up our columns and our rows. So we got 38 and 24, that's 62. 14 and 24 is 38. 38 plus 14 is 52. And 24 and 24 is 48. So we have 100 people in our survey. Then using 38 out of 100 is 38%. 24 out of 100 is 24%. That's a total of 62%. When it's 100 people, that makes it really simple. 14%, 24%, 38%, 52%, 48%, and then 100%. In part B, if a student owns an MP3 player, what is the probability that the student also owns a smartphone? So we want to look in that column. So they own a yes and a yes, so we got 38 people out of 62 in that yes column. So our probability is 38 out of 62, which can be simplified as 19 out of 31 in our survey, or 61.3%. And then finally, if a student owns a smartphone, what is the probability that the student also owns an MP3 player? So they have a smartphone and an MP3 player. That's 38 out of 52. And that percentage, 38 out of 52, can be reduced or simplified to be 19 out of 26 people, or about 73.1% of the survey. And that's the end of lesson 4.